Okay, find the value of x. You might look at this if you were paying attention in class and you know what I was getting at with the Pythagorean triples. You can look at this and you can say, oh, I know that it's already got to be 10 because this is the 3, 4, 5 scaled up by 2. This is 3 times 2. This is 4 times 2. That's got to be 5 times 2 or 10. Yeah? Straight away, easy. That's why I showed you. But let's pretend you didn't know that and you wanted to just test it. So you can just say 6 squared plus 8 squared equals x squared. Or another way you could do it is to say the square root of 6 squared plus 8 squared just equals x. Oops. And calculate it out. So the square root of 36 plus 64 is equal to x, or square root of 100, which is 10. X is equal to 10. Okay, keep going. We've got 16 squared plus 30 squared equals x squared, or I'm just going to start writing it like this. The square root of these squared, that should be said squared. Let me write that in there again. Plus 30 squared equals x, and then say, what is 16 squared? 256. What is 30 squared? 900. And then we add them together and we get 1156 is equal to x, square root of that. Now, I'm going to, over here on the side, I'm going to just do this 1156. I don't know what we're going to get there. I haven't done this yet. But if I wanted to use my calculator, I could just say, I'm going to do 1156 divided by 2. Then when I break that down, I'm going to get 2 times 578. Okay, and if I break that down, that's even, so I can do 2 times whatever half of that is, 289. Oh, that's interesting, because 289, if I'm not mistaken, is like 17 times 17. 17 times 17, yeah, 289. So that breaks down into 17 times 17, both prime. So then I can say, oh, okay, then that means that that's the square root of 2 times 2 times 17 times 17. And once I know that, I can say, okay, well, what am I doing here? What we're going to do is, if we see it in there twice, bring it out once. So we're going to bring out a 2. We're going to bring out a 17, and there's nothing left inside, so all we need to do is to multiply these together, and that is what we got. Okay, and let's go one more. Let's do this one. We say 65 squared plus 72 squared equals x squared, or remember, that's the same as the square root of 65 squared plus 72 squared. Okay? So what is 65 squared? 4,225. 72 squared? 5,184. And the square root of those numbers, when you add them together, is going to be x. So we add that with that. We get 9,409 is equal to x. Wow, I have no idea how to do this. I don't know how this breaks down. So I know that 10,000, it's close to 10,000, and 10,000 would be 100 times 100, right? So If I did 99 times 99, I get 9,801. So what about 98 times 98? Just typing stuff into the calculator and checking. Nope, not 98 times 98, still too big. What about 97 times 97? Oh, wow, that's what it is. The square root of this is exactly 97. And then that becomes your answer. And I just want to show you, because that was such a weird and big number, here's what I did there, just to be clear. I said, well, I know that 100 squared is 10,000, and it's less than that, so I'm going to go less than 10,000. I'm going to check numbers that are less than it and see what I get. And if I happen to skip right over it, like that's like that, if I did 98 times 98, I get 9,604. And if I happen to get to, like, let's say 97 squared, and I ended up with a lower number, I don't know why I wrote that. Let me clarify that. That should be a 9, not a 2. Okay. And if I did 97 squared and I suddenly ended up with a number less than 9,409, I'd know that it didn't work out perfectly as a perfect square, and I'd have to factor it the long way. Okay. But I knew it was close, and I figure until I check the numbers and I go from one number to another, skipping over it, maybe I'll land right on it. And I do. When I was checking these and going down by one each time, I saw that. And that's how I knew that it was that. Okay. Of course, if I was using a square root button, you could just type that in and square root it and see if it works out, and you would have found that out right away.